Hello everyone, welcome to my class. In my previous video, we talked about Heisenberg's uncertainty principle, which simply states that it is not possible to measure simultaneously the position and momentum of the electron with great accuracy. So, in 1926, Erwin Schrödinger developed an atomic model taking into account the wave as well as the particle nature of electron, and this is called quantum mechanical model of an atom. Now, quantum mechanics was developed by Erwin Schrödinger in 1926, and it is based on the wave motion associated with the particles. For the wave motion of the electrons in the three-dimensional space around the nucleus, he put forward an equation called Schrödinger wave equation, which states that del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square plus 8 pi square m upon h square e minus v psi is equal to 0. Now del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square. Here psi is representing the amplitude of the wave, whereas del square psi upon del x square means second differential of psi with respect to x-axis. Similarly, del square psi upon del y square means second differential of psi along the y-axis, and del square psi upon del z square means second differential of psi with respect to z-axis. Here m is the mass of the electron, E is the total energy of the electron, V total potential energy of the electron, psi is the amplitude, means the wave function of electron. After this, the same equation can be written in the form of shorthand notation, and that is h psi is equal to E psi, where h is a mathematical operator called Hamiltonian operator. And the solution of this Schrödinger wave equation for an electron in an atom gives two things. Number one, E, energy. Number two, psi, that is amplitude. So value of E represents the quantized value of energy which the electron in an atom can have, and the corresponding value of psi are called wave functions. Now, what is the significance of the wave function? Now, in case of light or sound, square of the amplitude of the wave at any point gives the intensity of the sound or light at that point. Similarly, square of the amplitude of the electronic wave, that is psi square, at any point gives the intensity of the electron wave at that point, which in view of Heisenberg's uncertainty principle means probability. That is, probability of finding the electron at that point. So psi square represents the probability of finding the electron at that point. The region around the nucleus, which represents the electron density at different points, is called an orbital. The wave function for an electron in an atom is called orbital wave function or simply atomic orbitals. Since an electron can have any wave function, therefore there are many atomic orbitals in an atom. Coming to applications of Schrödinger wave equation to hydrogen atom. Now, when Schrödinger wave equation is solved for hydrogen atom, the solution gives possible values of energy, that is E, and these values of energy corresponding to the energy levels which the electron in an atom can occupy. These values of energies are called eigenvalues, and corresponding values of wave function are called eigenfunctions. What are the features of quantum mechanical model of an atom? Number 1, electrons in an atom have only quantized values of energies, means those energy levels which have definite energy. Number 2, these quantized values of energies, they are obtained from the solution of Schrödinger wave equation. The values of the wave function psi are also obtained from the solution of Schrödinger wave equation. Number 3, the wave function psi is simply a function of coordinates of the electron and it has no physical significance as such. Means psi is not significant, but square of psi is always significant, and that gives us the probability of finding the electron at that point. Psi can be positive or negative, but psi square is always positive. Number 4, by finding psi square at different points around the nucleus in an atom, we can predict the region of space around the nucleus within which probability of finding the electron with a definite value of energy is maximum. And what do we call this space? It is called orbital. So wave function psi is called orbital wave function or simply atomic orbital. Number 5, since an electron can have many wave functions, therefore there are many atomic orbitals in an atom. Number 6, the orbital wave function contains all the information about an electron in an atom, and the quantum mechanics help to extract this information. Coming to now applications of Schrödinger wave equation to hydrogen atom. So we have already discussed that Schrödinger wave equation is solved for hydrogen atom because it is easier to apply it on hydrogen atom because of single electron in it, and its solution gives value of E. These values of energy corresponds to energy levels in which the electrons can revolve. Number 2, these values of energy are called eigenvalues, and the corresponding value of wave function psi are called eigenfunctions. That's all about Schrödinger wave equation.